So in the last video, we learned third and fourth lab assignment. Here we will learn the fifth lab assignment, that is design Verilog HTL to implement decimal adder. Here we write the Verilog code for decimal adder. We use a data flow program here, that is module decimal adder A B sum input 3:0. That is, it is the input of A and input of B is also 3:0. Output is 4:0 sum. Assign sum equals A plus B and module. So it is a Verilog program of a decimal adder. We see the output to this program. First we should select the signals of input A and input B. So the force value of input B is 9. We shall select the value radix as unsigned decimal, and the input of A is, the force value to the A is 6. So we see the display here, that is A 3:0 value will be 0110, B 3:0 value will be 1001, and sum of 4:0 is 0111. So here's it is the end of the fifth lab assignment. Let's see the sixth lab assignment. Design a Verilog program to implement different types of multiplexer like 2:1, 4:1 and 8:1. Before we see the code of this program, we shall see what is multiplexer. Multiplexer, also known as data selector. The word multiplexer denotes to create multitude. 2:1 multiplexer, it consists of two inputs D0 and D1. One select inputs S and output Y. 4:1 multiplexer, it takes 4 inputs and directs a single selected input to the output. 8:1 multiplexer, it consists of 8 data inputs D0 through D7. 3 inputs select lines S0 through S2 and a single output like Y. Let's see the Verilog code of 8:1 multiplexer. Here we see MUX module MUX S, D, Y, input 2:0 of S, input 7:0 D, output Y, register Y, always add S or D case of S. 0:Y equals D:0, 1:Y equals D of 1, 2:Y equals D of 2, 3:Y equals D of 3, 4:Y equals D of 4, 5:Y equals D of 5, 6:Y equals D of 6, 7:Y equals D of 7, end case and module. So you see here the output of 8:1 multiplexer, that is S of 2:0, D of 7:0. Value of S is 111 and value of D is 0110110, and the output will be Y, that is 0. You can see both thin lines and thick lines in the output. So now let's see 4:1 multiplexer code. MUX module MUX S, D, Y, input 1 of 0 of S, input 3 of 0 of D, output Y, register Y, always add S or D case of S. 0:Y equals 0 of D of 0, 1:Y equals D of 1, 2:Y equals D of 2, 3:Y equals D of 3, end case and module. So next 2:1 multiplexer. MUX module MUX S, D, Y, input 0:0 of S, input 1:0 of D, output Y, register Y, always add S or D case of S. 0:Y equals 0 of D, 1:Y equals D of 1, end case and module. Here you have the output of 2:1 multiplexer, that is S of 0:0 and D of 1:0. The value of S is 1 and the value of D is 0, 1, and the output Y is 0. Here we have 4:1 multiplexer output. We see S of 1 of 0 is equals, the value of is 1, 1, 1, and D 3:0 is 1, 1, 0, 0, and the output of Y is 1. So here's and the sixth lab assignment.